Good morning, Year 6. I hope you're all safe and well. Today is the 11th of June 2020 and we will be continuing our unit on statistics. So I'd like you to write down today's numerical date, the date in Roman numerals, and our learning intention today, which is to solve problems involving line graphs. For today's lesson, you will need a pencil, paper, you'll need your thinking hats on, as always. You will need the worksheet which was emailed to you this morning, which you'll also find on the school website. And if you wish to continue work, you may need your Mathletics login. So, as we have been doing this week, we've been focusing on percentage and finding a percentage of an amount. You'll remember yesterday we looked at finding a percentage which is a multiple of 10. And today we're going to have a look at finding a percentage which is using 1% to help us find other percentages. So, if we know how to find, can you remember how to find 10% of a number? What do we have to do? That's right, we have to divide it by 10. Because to get from 100 to 10, we have to divide by 10. If we want to find 1% of a number, what do we need to do? That's right, we divide by 100. Because to get from 100 to 1, we have to divide by 100. And that is going to be what we're going to use to help us with our problem solving today, with finding our percentage of an amount. So, I'd like you to start off by writing down 1% of 100, 1% of 400, 210 and 350. Then once you've done that, use that information to help you find 2%. So if you know that 1% is whatever it is, then what are you going to do to help with 2%? That's right, you're going to multiply that answer by 2. And the same with 7%, you'll multiply it by 7 and so on and so forth. So just as we have been doing, you'll find the colours match the advice given on the outside. And I'd like you to complete this grid as quickly as you can, setting your 10-minute timer and pausing the video here. Off you go. Now let's go through the answers. So, to find 1%, we do 100 divided by 1, and that gives us 1. And it's the same all the way across. So 350 divided by 100 gives us 3.5. Now, to find 2% and 7%, we multiply the answers to 1% by 2 and then by 7. For 11%, we can do the same. We can multiply the answer by 11, or you might choose to add together. You might choose to add together your answer to 10% and your answer to 1%, and then get your answer. So if you were out and you wanted to do it mentally, that might be the best way. To find 10%, work out 1% and add it together. We know 10% is 35, 1% is 3.5. When you add them together, you get 38.5. To find 52%, however, we could still find 1% and multiply it by 52. We could still do that, or if we were trying to do it mentally, it might be best to find 50% and then add that to the 2%. So we can always partition the percentage as well to help us work out something quickly and mentally. So there isn't always just one method that can be used in maths. In fact, there rarely ever is. There's always a number of methods, and different people will use different methods, and it's whichever way works best for you. Okay, as long as you get to the right answer, the method doesn't matter. Okay, always just try and think of the most efficient method that works for you. And the same with 64% again. So taking the 1% and multiplying it by 64%. That's one way. But you might also, as we just discussed, have found other ways to do that. So well done. And having had a look at the work that's been sent in, I can see really good progress with finding a percentage of an amount. So well done to all of you. So today's lesson we're going to be focusing on problem solving involving line graphs. So let's look at some examples together. These 4 temperature graphs show the temperature over different times in different places. Can you see any similarities or differences between the graphs? So I want you to just pause the video here, have a look at each of the graphs and just think what is the same and what is different. And you might want to make a note of it as well. What is the same and what is different? You can use the title of the graphs to help you. So you might say the line graph showing Cyprus and the line graph showing Mexico have this in common. Brilliant. So what do they have in common? Before we go on to the question, we can see that Cyprus and Mexico both have their times written in 24-hour clock format. We can see that they go from 9 o'clock all the way up to 1500 hours. So that's something that they have in common. We can see that Barcelona, the time has been recorded hourly and it goes in 12-hour format. Okay, so we're using AM and PM. Whereas for Koh Samui, we go from 9 o'clock all the way up to midnight, and that time is also recorded. That time actually only records the time in PM, so we're only talking about the evening on that line graph. Okay, so all the line graphs show time recorded differently, and that's going to help us when we're answering the questions. Look at the following questions and answer and work out which graph they could be referring to. So remembering those clues that we've just looked at. What was the temperature between 9 o'clock and 1500 hours? What was the temperature difference, between 9 o'clock and 1500 hours? So it doesn't tell us which line graph we're talking about, but we have to work it out. So we're looking at the temperature between 9 and 1500 hours. First of all, we need to think, which line graphs could we be talking about? Could we be talking about Cyprus? Yes, we could. Could we be talking about Koh Samui? No, we can't. Could we be talking about Barcelona? No, we can't. And could we be talking about Mexico? Yes, we can. So those are the two line graphs that we are referring to. And the answer is, there was a difference of 5 degrees Celsius in Mexico or 21 degrees Celsius in Cyprus. So if you look at Mexico, we can see it was just below 10 degrees Celsius at 9 o'clock compared to 30 degrees Celsius at 1500 hours. And that was Cyprus. And in Mexico, it was about 25 degrees Celsius at 9 o'clock, and then it was 20 degrees Celsius at 1500 hours. So you might also have said Barcelona there, because we know that 3 p.m. is the same as 1500 hours. But in this case, the times are going to be written in the same format as those written on the line graph. Let's try another one. Look at the following questions and let's see what graph they could be referring to. For approximately how long did the temperature remain stable at 20 degrees Celsius? So if something remains stable, it means that it stays the same, it's consistent. So for how long did the temperature remain stable at 20 degrees Celsius? Think about which graph we could be referring to. I'll give you a clue. There are two graphs that we're referring to. Super. Let's see if you manage to spot them. It's Cyprus and Koh Samui. Both of them have the temperature remain stable at 20 degrees Celsius for a period of time. And for how long, we can see that in Cyprus, it was for 1 hour, from 11 o'clock to 12 o'clock. Whereas in Koh Samui, it was between 10:45, just after 10:45 to just after 11 o'clock. So it's 15 minutes. Well done if you managed to get that. Next question. What was the temperature at 10:30 a.m.? So what's our clue? Well, we know we're looking for a line graph that shows us the time at 10:30 a.m. See if you can spot it. Put your finger on it now. Super. And then I want you to have a go at reading the temperature at 10:30 a.m. What was it on that line graph? Now I know most of you probably got this one and you spotted that actually there's only one line graph that shows that information, and that's Barcelona. So Barcelona at 10 a.m. the temperature at 10:30 a.m. the temperature was 15 degrees Celsius. So well done for those of you who got that. We can see it doesn't actually show us 10:30 a.m. on there. It shows us 10 a.m. and 11 a.m. And then we have to find 10:30. We know it would be somewhere in the middle of those two times. And we follow the line up until it hits the green line. Let's try another one together. How much did the temperature increase between 9:30 p.m. and 10 o'clock p.m.? Find the graph. Put your finger on it. Did you spot it? That's right, it's Koh Samui. So between 9:30 and 10 p.m. we can see that the temperature increased from 10 degrees Celsius all the way up to 20 degrees Celsius. So it's increased by 10 degrees Celsius. You know that's the only line graph that can answer the question because it's the only one showing the evening using the 12-hour clock. Let's try and solve a little problem together. Here on the left we have the family, the Kellets. On the right is the family, the Mysteries, and they are going on a holiday. They've decided they're going to go on holiday to Cornwall. And they're going to travel to Cornwall separately. And they'll share the accommodation when they get there. So they'll share this place that they'll be staying, but they're going to travel separately. They have booked an apartment with a shared swimming pool. And while on holiday, they plan to go swimming, eat at local restaurants, fly kites on the beach, even take a boat ride and go fishing. Sounds like fun, But first, they need to get there. The Mystery family are going to travel to Cornwall by car, whilst the Kellets are going to travel by train. So here we have a line graph showing how long it takes each of the families to travel to Cornwall. The Kellets' journey is shown with a purple line, whereas the Mystery's journey is shown with a green line. Before we start, what time did the Mysteries start their journey? Excellent. They started their journey at 8 a.m., 8 o'clock in the morning, whereas the Kellets started their journey at 8:30 in the morning. What time did the Mystery and the Kellet family finish their journeys? That's right, the Mystery family finished theirs at 2 o'clock, or 1400 hours. Whereas the Kellet family finished their journey at 13:30 or 1:30 p.m. Well done if you could answer those questions. So just as we've discussed, when they started and when each of the families started their journeys, so I know you can all answer that. Now, which family had the fastest journey? We've talked about the times that they started their journey as well as the time that they ended their journey. But which family had the fastest journey? That means that their time was the shortest. Well, even without doing any working out, we can already tell which family had the fastest journey. It was the Mystery family. It was the Kellet family, because the Kellet family started their journey at 8:30 and they finished their journey at 1:30. Now from 8:30 to 1:30, that's 9:30, 10:30, 11:30, 12:30, 1:30. That took them 5 hours. The Mystery family started their journey at 8 o'clock and didn't finish until 1400 hours. So if we count from 8 to 1400 hours, we go 9, 10, 11, 12, 13, 14. That took them 6 hours. So we know that the Kellet's family's journey was quicker. The The Mystery family stopped at motorway service stations twice. At which times did they stop? And how long did they stop for each time? So how will we know how to identify a stop on our line graph? Well, we'll know because the distance will stay the same. When we stop, we're not travelling any greater distance. So look for where on the line graph the distance stays the same. We can see that the Mystery family stopped at 10 o'clock and they stayed wherever they stopped. They stopped at the motorway stations. We know they stayed for half an hour because we can see the distance starts to increase again at 10:30. Between 10 and 10:30, they were stationary. We can also see that they stopped again at 12 o'clock and they didn't move again until 1300 hours or 1 p.m. because again we can see that the distance stayed the same. So well done if you managed to spot that. The Kellett family also stopped at different times during their journey. How many times did they stop? Can you think of a reason why their journey stopped? So they were on the train. Why do you think they might have stopped? I mean, the train doesn't stop moving, surely. So why have they stopped? What could it be? When did they stop and how long for? Remember how we found the Mystery family, how we were able to identify when they stopped? We'll use that to help you with finding the Kellett families. Excellent. So the Kellett family stopped at 3 different times. We can see they stopped at 9 a.m. or 9 o'clock and they didn't move again until 9:30. We can see they stopped at 10:30 and didn't move again until 12. And we can see that they stopped at 12:30 and didn't move again until 1 o'clock. So they stopped a number of times and still managed to get there quicker. Why do you think they stopped at those times? Well, they could have stopped at different stations and they could have changed trains. So that's just one of the reasons why. They could have stopped and had to wait for another train at the station. Do both families travel the same distance overall? Pause the video here and just think they both started from the same place, they finished at the same place, but have they travelled the same distance? Yes, both families travelled 265 kilometres. One family did it by car and the other chose to do it by train. Which family had travelled the furthest by 10 o'clock? And how far had they travelled? So you'll need to follow the x-axis on our line graph until you hit 10 o'clock. Put your finger on 10 o'clock and then travel upwards until you hit the purple line that represents the Kellett family. Do the same once you've done that until you reach the green line which represents the Mystery family. When you hit those lines, you're going to need to then travel horizontally to the left until you hit the y-axis, which represents distance in kilometres. And once you've done that, then you'll need to identify how far each family had travelled by 10 o'clock. Pause the video whilst you do that. Excellent. So at 10 o'clock, the Mystery family had travelled the furthest because they had travelled 115 kilometres compared to the Kellett family who had travelled only 90 kilometres. Well done if you managed to get that. The Kellett family stopped for half an hour at 12:30. How far away from their destination were they? So you need to follow the x-axis along until you find 12:30. And then once you hit 12:30, you need to travel upwards until you hit the purple line, which represents the Kellett family. We can see that at 12:30, the Kellett family were at, that's right, they were at 230 kilometres. That's how far they had travelled. Their destination, the total amount of distance they need to cover for their journey is 265 kilometres. And we know that because we know if we follow the y-axis, we're going up in intervals of 10 kilometres. So we know they travel 265 kilometres in total. Now, from 230 to 265, what is the difference? So we can see that from 230 to 265, there is a difference of 35. So they still had 35 kilometres left to travel. So well done if you managed to get that answer. So what next? I'd like you to have a look at the worksheets that were sent to you this morning, and I'd like you to complete the graphs and the problem solving questions. If you have any problems or if you need any help, remember we are always just a click of a button away, so feel free to send us an email. Again, as usual, well done to those of you who have been sending in work still. You're doing amazing, and the email address is coming up. Remembering to email us your work at the email address shown, yr6@grange.harrow.sch.uk. Have a great day. Bye.